Welcome to solverfy.
Okay, so for this problem, we have a coil and we're asked to find first the flux lengths through it. So we're given some information. So there's 30 turns and the radius is 0.1 meters. And then the magnetic field through the coil is 2.6 times 10 to the minus 3 Tesla. And I want to find the flux link, what was it called? It's kind of new vocabulary for me. Magnetic flux links. But I looked it up. It's okay. It's easy. It's just phi is NBA. And then A is the cross-sectional area. So NB pi r squared. And then when I plug that into a calculator, I obtained 2.45 times 10 to the minus 3 Tesla meter squared. And then the next part asks, oh, stop lagging. I'm gonna go slower, I guess. The next part asks, when you turn on the current and then the flux vanishes, what's the inductance of the coil? And so we're kind of not inducing. What is that? Not inferring that the current through the coil creates a field that balances the external field. And so, and we're first given that the I is 3.8 amps. I'll go ahead and write that out in the givens. And we want to get the inductance of the coil. And so with this one, we want to first get the form of the field of a coil. So it's B is mu naught, the number of turns per length. I should use a lowercase l for the length. Times the current, bunny, as I like to remember it. And so, okay, hold on. Sorry, I'm trying to interpret my notes. I actually got slightly confused because of the different L's. So, L and length are not the same thing. What is the inductance of the coil? Let's see. Maybe you don't actually need this part. So I'm just going to put this to the side. So we know that inductance is equal to, the book gives the formula N times the flux, so the magnetic flux links divided by the current. And so I guess we actually know this. This is the 2.45 10 to the minus 3 divided by the current, and we have that I, we have the N phi, so that's this thing. I guess I'll call this N. Actually, what is the symbol for flux for the magnetic flux links? So that's N times phi. Okay, yes, that works out. Okay. And so, yeah, so if you plug in 2.45 divided by 3.8 amps, then I got 6.45 times 10 to the minus 4 henries. Sorry about the confusion. I think I kind of started here and then didn't cross that out in my notes. So that actually wasn't the way to go. I did these problems much earlier than I recorded them. Great.